Even today, there is an aerodynamic phenomenon that is horrifying to most of airplane pilots: the compressor stall. This phenomenon can be triggered by a simple incident, such as a bird strike. A compressor stall can lead to a total loss of engine thrust, severe vibrations, and loud bangs in the engine. It can even have a catastrophic effect, such as complete engine failure. Let's see what causes compressor stall and how to avoid it. The internal portion of an aircraft engine is shown here. The synchronized operation of the fan, compressors, combustion chamber, and turbines generates the necessary thrust to move the airplane forward. You should note that in a jet engine, only a small portion of the incoming air goes into the combustion chamber. The rest bypasses the core engine portion. From the air that enters the combustion chamber region, a large amount goes to the cooling of the combustion chamber rather than actually being combusted. Let's zoom into a particular section of this engine, the compressor. The compressor is the part which squeezes the incoming air and greatly increases the pressure of it. They, in fact, transfer energy to the fluid. This engine has two compressor units. You can see more details of the compressor here. The stator blades are attached to the casing, and they make sure that the compressor rotor blades receive the airflow at the correct angle. The compressor rotor blades have an airfoil cross-section. To understand the physics of a compressor stall, let's first learn the physics of airfoils. An airfoil produces lift when fluid flows around it. With the variation in angle of attack, the flow around the airfoil changes. However, if you increase this angle beyond a certain limit, you will notice that the flow streamlines get separated. Vortices will form on the top surface of the airfoil, and reverse flow happens in this area. Here you can say that the airfoil has stalled. It should be noted that with a rotating blade, the angle of attack is relative to the motion of the blade. Now consider the situation in a bird strike. The obstruction caused by the bird disturbs flow pattern at the engine inlet and can drastically change the flow angle of attack at the compressor inlet. If this angle of attack is too high, then this results in flow reversal and compressor stall. During a compressor stall, the compressor is no longer able to force the incoming air into the combustion chamber, and this causes that chamber area to suddenly be starved of air. This means the cooling in the combustion chamber is drastically reduced, and the temperature in this section of the engine rises dramatically. The big question is, what happens to the compressor outlet pressure? There are two possibilities for this. It can either increase or decrease. To get an answer for this question, we should also learn about the characteristics of a compressor. Consider this experimental setup. If you reduce the compressor mass flow rate with help of a cone, the pressure versus mass flow graph will look like this. You can see that after reaching peak pressure, the pressure then drops. This is due to the compressor stall. A low flow velocity can lead to a high angle of attack, and thus compressor stall. This graph is extremely critical in understanding the consequences of a compressor stall on an engine. Assume the initial compressor operating point is A, and due to the compressor stall, the point moves to B. Here, the pressure at the compressor outlet drops drastically, and there is a huge drop in airflow. The air available is insufficient, and therefore only a portion of the fuel gets burnt. The very hot, unburnt fuel, which escapes through the back of the combustion chamber, will meet the oxygen-rich bypassed air, and there will be sudden combustion. Now, for the second possibility, let us assume that due to stalling, the initial operating point A moves to point C. Here, at the compressor outlet, the pressure increases suddenly, and a slight drop in the mass flow rate occurs. In this case, there is sufficient air available for complete combustion of the fuel, but not enough for sufficient combustion chamber cooling. These conditions and the high pressure in the middle of the engine causes sudden explosions, and the exhaust can escape through either side of the engine. This process can be repeated several hundred times in a second until pressure equilibrium is achieved. This is known as a compressor surge. A compressor surge causes loud banging noises and severe engine vibration. If not properly controlled, it can even lead to total engine failure. It is quite interesting to realize that the aftermath of a simple bird strike can lead to such horrifying incidents. The other causes which can initiate a compressor stall or surge are listed here. The big question here is, how can pilots overcome such unpleasant events? Some compressor stalls are self-stabilizing, but if it is not, they should take the necessary action. The wrong compressor blade angle of attack and a too rich fuel-to-air ratio are the main causes of compressor stall. So by correcting these parameters, one can overcome a compressor stall. You can see a variable inlet guide vane arrangement at the front of most jet engines. Adjusting the angle of these blades will largely correct the angle of attack of the rotor blades. In addition, the use of bleed valves to blow air out and increase the airflow will also greatly reduce the effect of a compressor stall. The other technique is to limit the fuel supply by controlling the throttle. We hope you have enjoyed the explanation of how a small disturbance can lead to huge instability within a jet engine. Another interesting phenomenon associated with this topic is a rotating stall. We plan to release it soon. Please support our educational activities at patreon.com and don't forget to subscribe. Thank you.